Hello students, and a very warm welcome to today's class. We are going to look closely at basic information and communication technology skills. Focus your attention and let us begin our journey into the digital world. Here is what we are covering today. We will start with the broad world of ICT.
Okay, let's dive right into our very first topic, Section 1, the world of ICT.
So, what exactly do we mean when we say ICT? It stands for Information and Communication Technology. Simply put, these are the diverse technological tools and resources we use to communicate, create, store, and manage information. I want you to just take a moment and look around you. Think about how these tools completely surround you in your daily life. Every single time you send a message, search for information for your homework, or watch a digital broadcast, you are using ICT.
Think of ICT as standing on four main pillars. First, computers, which we use at work and home for almost all our complex tasks. Second, the internet, our primary tool for finding information and communicating globally. Third, smartphones, allowing us to talk, browse, and check emails on the go. And fourth, broadcasting technologies, like TV and radio for mass communication. To understand how practical this all is, consider a future job search. You will use the internet to search for the job, type your resume on a computer, email that resume, maybe give an interview over a smartphone, and finally receive your offer letter by email. All four pillars working together for your success.
However, the way we use these tools changes quite a bit depending on where we are. Notice the contrast here. At the workplace, ICT is highly productive and serious. We use it for online banking, writing research papers, creating documents, calculations, and presentations. But at home, our use of ICT is often focused more on entertainment and staying connected. We watch television, use our smartphones for social media, play games, and make video calls to our relatives. The tools are similar, but our purpose is very different.
Section 2, mobile devices and gestures. Let us transition from that big picture down to the smartphones and tablets we hold in our hands every day. When you turn on a mobile device, it comes with built-in software called default applications, or simply apps. I want you to picture the screen of your own smartphone, or perhaps your parents' phone. You will almost always see the phone app for calls, the calendar for appointments, the camera for capturing memories, mail for messages, and the gallery to store those photos. You also have maps for directions using GPS, a browser to visit websites, and a clock for your daily alarms. These are really the basic building blocks of any mobile device.
But how do we actually interact with these apps? Since these devices don't have physical keyboards like older computers, we use touchscreen gestures. Imagine holding a phone and performing these actions on a screen as you listen. We tap once to click. We tap and hold, which is very similar to right-clicking on a computer mouse. We drag an item by tapping, holding, and moving our finger. We swipe by sliding our finger quickly across the screen. A double tap often zooms out, and a pinch, bringing two fingers together, helps us zoom in.
Section 3, Computer Input and Output. Moving on from mobile screens, let us now look closely at the traditional computer system.
Before we look at the parts, I want to ask you a very interesting question. A computer is just a machine, right? It does not speak English or Hindi natively. So how do we talk to computers, to give them instructions, and just as importantly, how do they talk back to us with the answers?
Well, we bridge this language gap using input devices. We use a keyboard to type, a mouse to point and click, and a scanner to make digital copies of our paper documents. But look at these specialized ones. This brilliantly illustrates how clever ICT can be. MICR, or Magnetic Ink Character Recognition, is used by banks to read the special account numbers at the bottom of checks very quickly. And OMR, Optical Mark Reader, this one is very relevant to you as students. When you shade those little circles on a multiple-choice exam sheet, an OMR device shines a light beam to detect your marks and grade your paper automatically.
Once the computer processes our input, it talks back to us using output devices. You are already familiar with the monitor screen and speakers or headphones for sound. But note the difference in printing. A standard printer gives us hard copies of our documents on normal A4 paper, but a plotter is a very special output device. It acts like a printer using pens and markers, and engineers use it to print massive building plans, maps, and large graphics.
Section 4, CPU, memory, and storage. Let us guide ourselves deeper inside the machine, right into the computer's actual brain. Inside the system, memory is divided into two very important types. Students, please pay close attention to this, as it is a crucial difference. RAM stands for Random Access Memory. It is volatile, which means it is temporary.
If the power suddenly goes off in your house, the RAM forgets everything it was doing. On the other hand, ROM stands for read-only memory. It is non-volatile. The instructions inside ROM are permanent. It remembers everything even when the power is completely shut down. Now, because RAM is temporary, we need a place to permanently save our files, movies, and homework. This is called secondary storage. We use hard disk drives inside the computer or portable ones like a small pen drive. We also use optical disks. A standard DVD holds up to 17 gigabytes of data. But please notice the Blu-ray disc. By using a blue laser, a Blu-ray disc can pack 25 gigabytes of data per layer. That means it holds about 5 times more data than a standard DVD.
When we talk about all this storage, how do we actually measure the data? Just like we buy vegetables in grams and kilograms, computers have memory units. Let us walk up this scale together. The smallest unit is a single bit. 8 bits come together to make a byte. 1024 bytes make a kilobyte or KB. Then it grows to megabyte, gigabyte, and finally, terabyte. Take a moment to absorb how the size of data grows exponentially at each and every step.
Section 5. Exploring the Internet. Let us zoom back out to see how all these devices connect globally.
We connect them all using the Internet, a massive global network. Think about the incredible utility of the World Wide Web in our daily routines. We use it to search for exam results or the daily news. We use it for entertainment, like streaming movies and music. We rely on it for social networking, online learning for classes exactly like this one, booking train and flight tickets, and online banking. It is truly the backbone of modern society.
Section 6. Understanding electronic mail. We now transition to our final topic, a foundational tool for global, professional communication.
Now, what's really interesting about this slide is how it breaks down the essentials of email. The advantages are very clear. It is incredibly fast, almost free, and you can send attachments to multiple people all at once. But we must be careful. Emails can contain viruses, they can be intercepted by hackers, and readers may lose interest if your messages are too long. Managing your mail, however, is quite easy. Incoming mail goes to your inbox. Unfinished messages wait patiently in drafts, and most importantly, suspicious emails are automatically thrown into the spam or junk folder to keep you safe. My dear students, we have covered a lot of ground today. We have learned the anatomy of ICT, starting from basic mobile gestures all the way down to how memory is stored and how global emails are sent. I want to leave you with this thought-provoking question. Now that you understand these foundational tools, how will you use them to study better, innovate, and build your bright future? Thank you so much for paying such wonderful attention today, and keep learning.